Hi students, we're going to go over your study guide on work and power. You will be turning this in on the day of your test. Whichever ones you get wrong, please mark with a different colored pen or pencil and correct it, or fill it in if you left it blank. Okay, so we're going to define work first. Work is the transfer of a force over a distance in the same direction as the force. Letter B, work can also be defined as a transfer of energy. Letter C, in order for work to be done, force and displacement must be in the same direction. Letter D, I'm going to give you one example of work that is done. You may have the other ones on your sheet. Mine is a teacher pushes a chair across the floor. An example where work is not done using the same kind of scenario is a teacher sits in her chair and explains work to her students. For number F, the three scenarios, you're going to explain why work is not done or is done. The first one, a woman preparing for a trip lifts her suitcase from the floor to the bed so that she may pack more easily. Work is done because she applies the force on the suitcase in the same direction she's moving it. The next one, a man spends 5 minutes thinking about the most efficient way to decorate his roof with Christmas lights. No work is done because there's no force or motion. Remember, in order for work to be done, a force has to be applied, which moves the object in the same direction as the force applied. Next scenario, a student carries his book bag down the hall. No work is done because the force is applied upward on the book bag, but it's moving forward. The force and displacement are not in the same direction. Letter G, you are to identify which of the pairs in each scenario illustrates more work being done. For letter G, we have two scenarios. A boy helps a teacher by lifting a 200 Newton box of books 1.5 meters from the floor to the desktop. The same boy lifts a 500 Newton box of books the same height. We are going to say the second one because, first of all, remember, work is force times distance, and the displacement's the same for both. They're both being lifted the same height. The greater work is done when you must exert a greater force. So because the box here is a greater force, there is more work being done by the second scenario. All right, the next one, a girl throws a 1 kilogram softball with a force of 50 newtons, a distance of 25 meters. And the next option is the same girl throws a softball with the same force, a distance of 17 meters. So which one is showing more work is going to be the girl that throws the 1 kilogram softball with a force of 50 newtons because work is force times distance. And the force applied is the same direction in both scenarios. So greater work is done when the ball experiences a greater displacement. Moving on to power, we are defining it first. Power is the rate at which work is done. And how are power and work related? Well, power can be increased by doing more work. And this is a direct relationship. Okay, so if more work is done and you have the same amount of time, then your power is going to be greater. Power is work divided by time. Letter C, you are now supposed to identify which of the pairs in each scenario illustrates less power being generated. Okay, not more, but less power being generated. So our first example, a woman pushes a cart with 95 newtons of force 3 meters in 10 seconds. Or a man pushes a cart with 95 newtons of force 3 meters in 13 seconds. The correct answer is the man, because remember, power is work divided by time, or force times distance over time. Since both people exert the same force over the same distance, meaning they're doing the same amount of work, the man generates less power because it takes him longer. Then the last scenario, where is there less power being generated? a 340 Newton student climbs the stairs in 14 seconds, or a 420 Newton student climbs the stairs in 14 seconds? Well, you should have put the first one. And the reason is because power is work divided by time, or force times distance over time. And since both students are climbing the same amount of stairs in the same amount of time, that student that weighs less, okay, remember, weight is a measure of the force of gravity, that person will generate less power. And that also goes along with the lab we did on Can We Feel the Power? Can You Feel the Power lab? All right, so make sure you put at the top of your page how many you got wrong or how many you missed, and you'll be turning this in on the day of your test.